So now I'm talking about inequalities in one variable. Yesterday it was first degree equation one variable. I did the video, the pre-video. So today, this morning, I started with inequality one variable. So the graph of linear inequality is one variable it's one variable in a number line. So we use the open cycle to represent greater than and less than. That is what you are seeing right here, open cycle here. And a closed cycle represents less than equals to and greater than equals to. So this is what you are seeing here also, a closed cycle. Because I shaded the cycle, so it's closed. So that is also because you can actually use your number line to solve an inequality, so I can get the intervals between them, or you solve it the normal algebraic way, and we're going to get there as the more we go into the class. So now, a linear inequality is a mathematical statement that relates a linear expression as either less than or greater than another. So yesterday I told you that what makes an equation, in that video, why I say what makes an equation is because of the equal to sign there. But if you see this one, there's no equal to sign, so it's an expression. You can't call it an equation. The less than greater than sign is not an equal to sign. Because you can't call this, you can't call inequality an equation because there's no equal to sign. It's an expression. So the solution of a linear inequality. The solution of a linear inequality is a real number that will produce a true statement when substituted for the variables. Linear inequality have either either many solutions or no solutions. What she's trying to say is that it depends on what you are solving. If I give you a particular question now, and the particular answer one that give you the specific answer is a true solution, and the other one is not the solution. Like for example, this example I gave here, x is equal to -4 and x is equal to 6. Solution to this, now they're asking which of this and this is a solution to this. So we solve both of them by substituting our 4 into as x, because our x is -4 here. So when we see x, we put our -4 there, and what we did here, and we solved it, and we got this. So yeah, we substituted 6 as x because our x was 6 here, and when we solved, we got this answer. And look at very well, they said 5x plus 7 is less than 22. So if you look at here very well, this is -13. -13 is less than 22. Yeah. But if you look at this place here, 37 is greater than 22. So this solution is false, and the solution is correct. So after that, the other steps actually you can use to solve linear inequalities. The other steps you can actually use, not only the table step and substitution steps. They have the addition and subtraction of real numbers from both sides of inequality, and also have multiplication or division or dividing both sides by positive real numbers to create equivalent inequalities. So now I give an example. This is an example now. 10 is less than -5. So now we are subtracting 7 from both sides to give us, you can actually use any number actually. I decided to use 7. I decided to subtract 7 from both sides. So now here now is what 10 minus 7 and greater than 5 minus 7. So when you finish solving, you get 3 here and you get -12 here, to tell you that 3 is greater than -12. On the number line now, one line like this, I can't write and video center. And one line is like this. This is our negative side, it's a positive side. So you see 3 is greater than -12. It will be going towards this direction. we're going towards direction greater than minus 12, so going towards that direction. We'll say 12 and 12 will come towards to meet 3, like that, and so on, like that. So it's another example talking about dividing both sides. That is for the other step. I use the same, so I divide both sides by 5 to get our answer. I see here 2 is greater than minus 1. But in any way, 2 is greater than minus 1. So when I divide both sides by 5, as we said, we got our answer to know that 2 is greater than 5. So when you are doing, if you are dividing, you divide with something that can go through both of them without reminders. That's how we are going to divide with. So then I have general properties of inequalities. That's one of the major things you're meant to know. The general properties of inequalities. If you know these properties, there's no inequality I will come to where I can solve. There are other complex properties, but these are the major ones I'm meant to know now for one variable. For inequality in one variable, because when you go to inequality in 2 variables, 3 variables, so you see different properties. So this is for a linear inequality now. So now addition property. If A is less than B, then AC is less than BC. No matter how you do it, if A is 5 is less than 6, then 5 plus 1 is less than 6 plus 1. And you want to add it with to give you, it will be less than what your B. That's the multiplication properties. If A is less than B and C is greater than 0, so AC is less than BC. So now that I want to do it, if A is less than B and B is greater than 0, that means if B, if you want to say if C is greater than 0, yeah, if your C should be 10 times, and your A is, let me say your A is 5, your B is 6 again, and your C is 3, because 3 is greater than 0. 3 times 5 will give us 15. 3 times 2 will give us what? So you see, your AC is going to be less than your BC. But when your A is less than B and your C is less than 0, then it also will be minus 1 and -2 minus 3. Then your AC will be greater than BC, because if your A is 5 and your B is 6 and your C is -2, 5 times -2 is -10, and 6 times -2 is -12, and -10 is greater than -12. So your automatically AC is greater than BC. And so other property you're going to apply: A is greater than equal to B, and A is less than B, and A is greater than equal to B, and A is greater than less than B. That's what property meant to know. So it's also something meant to know. Notes. So I wrote it notes. You must know this fact. When multiplication by a negative reverse inequality, and it also applies to division. So it's like it's one multiplication by a negative number. The sign, this sign here, if it's like this before, when you multiply it by a negative number, it turns the other way around. The sign changes. It also applies to division also, because once you multiply by a negative number, a number that have negative sign on the front, the sign of inequality changes. Now it goes the reverse way. No matter how, if it's less than equal to, if you multiply with a negative number, it will go to greater than equals to. It will just become the reverse of the whole stuff. So now let's say demonstrating the addition property. So I want to show you some example how to actually solve an addition property. I gave you this 3, I did this 2, and I did the 2 first 2. You're going to do this last one yourself, at least to make yourself perfect. So x minus 15 is less than 4. So I added 15 to both sides to eliminate this 15 from the equation. You know that one when I say you isolate the terms. I'll tell you what I told you here, but now we added 15 to both sides. Then this 15 cross out 15. You get 15 plus positive 15 is 0. So we have x on its own. Then I was clearing x. And here now 15 plus 4 plus 15 is what is 19. So s is less than what? 19. So same thing for this one too. That's how what we did again. We just allocated the terms and we just added 1 to both sides. We added 1 to both sides. We added 1 to 6 and we added 1 to the other side. So -1 plus 1 is equal to what? 0. And 6 plus 1 is what? 7. So 7 is greater than equals to x. So we just simplified it, then cleared x. That's what we did here, just like in the equation part. So now I'm demonstrating the multiplication property. Now I did this two also, this first two. I'm going to do this last one yourself. That's on yourself. So now solution for the first one. Now to isolate, to allocate terms, and so I can isolate the s on its own. I multiplied both sides by 1/3. I multiplied by on both sides. 1/3 here, 1/3 here. This 3 will cross this 3, remaining 1 times x. Yeah, 6 will cross 3, will give us what? Will give us 2. It will be 2 times 1. So that will happen here. 1 times x is x, 2 times 1 is 2. So x is less than 2. We're looking for a way to isolate the s and make s be on its own. That's what we're trying to do. I just solve this other one too. This one is -2 minus 1 is greater than or equals to 5. First of all, what you do is collect like terms. What you do, you gotta collect like terms, allocate terms to itself. This one, this one here, and this one here are the same. So you associated with ourselves. That's what I actually did here. So this one moved from here to here, it became positive. Then -2x greater than or equals to 5 plus 1. -2x equals to 6 times 1. I multiplied both sides by the reverse of this. That's I multiply both sides by -1/2, so that I can isolate the minus sign in front of the x2 and the 2 out. So when you do that, locally this 2 goes with this 2. -1 times x will give you x, and that is it here. The same thing happens here. Each can go here. When this enters here, it becomes 3. 3 times -1 give us -3. That's just it for the multiplication this thing. It's just that for multiplication property. You can actually try the last one. It's not hard too. What you just do in that last one is to collect like terms first. You collect like terms first. I want you to do is take 5 to this side, and 5 will become 1 negative. 5 will become 1 negative, and 10 minus 5 is what? Is 5. Then to isolate s and move this minus here, basically what you do is to multiply, you times both sides by -1, or divide both sides by -1. If I by -1, you get rid of this one, of this x here, of this minus here, and here become -5 at the end of the whole equation. So the answer here will be x is close to -5. Anything you solve and not get -5, and you're wrong. So now we're coming back to our major topic: inequalities in one variable. So what is inequalities in one variable? What is it? So inequality in variable is a linear inequality. It's also called a linear equality because it's dealing with just one variable. So just like first degree equation, it's called a linear equation because it's dealing with one variable also, with one equation. So first degree equation is just dealing with one exponent, x power 1, and this one now is a linear inequality, was dealing with with one variable only. So say it's a linear inequality that can be written in one of the following form, where a and b are real numbers. So yeah, what I'm trying to tell us here is that and a is not equal to 0. Now that tells you a plus bx is less than 0. A plus bx is greater than what? 0. A plus bx is less than or equal to 0. And a plus bx equals to 0. That's when a is not 0. all this statement is what is correct. That tell me 5 plus 2x is less than 0. 3 plus 6x is greater than 0. 10 plus 5x is less than or equal to 0. Like that. So now, as for the other part, say we can perform the same operation on both sides of an inequality, just as we do with equations. We combine like terms and perform operations to solve. We isolate the variables, and variables is what is x. So to solve any equation, we have to isolate what the variable. The variable is what s, bringing s to one side of the equation on its own, and the numbers to the other side of the equation. That's what I was doing here. So now, to do that, now you have to learn how to solve inequality algebraically. So solving the inequality, now I brought this an algebra equation, looking like an equation and a first degree equation, but there's no equal to, so this one is like a first degree expression. So someone that is even equal to sign, but it's a greater than equal to sign, you can't put equal to there. You bring a greater than equal to sign there. So what we did first, we collected like terms to isolate the variables. So every term carrying x came to the other side, and every term without x went to the other side of the equation of the inequality. Then so we do is simplified. Once simplified, we got this answer minus 17x greater than or equals to minus 17. Now to clear x, we divide both sides by minus 17. So when you divide minus 17 from here and minus 17 from the other side, x is greater than or equals to 1, and that will be our final answer. So now, solving inequality with fractions, so it's more complex, like very complex. First of all, what we also do first is always collect like terms. This is representing an equal to sign here. You collect like terms. So collect like terms. This one will come and meet his x fellow brother here, and so on be on his own here, isolated here. And after that, you write a fraction with common denominator. This and this have common denominator. This is 4 times 3 give us 12. This one is left on its own. So now the LCM here is already 12. 12 in 3, 12 in 4 give us 3. That's why we got this 3 times 3, yeah. And 12 in 2 will give us 4. So yeah, 12 in 3 will give us 4. 12 in 3 will give us this 12 here in this 3 will give us 4. To give us 4, that's why I have this 4 times 2. First of all, we find the LCM. LCM is 12. Then our 12 in 4 will give us 3. And 12 divided by 4 is 3. So 4 divided by 12 is 3. And I call it 3 times 3 is what is 9. What is 9 here? Then 12 in 3 is 4. Because 3 will go into 12 4 times. So when you multiply 4 times 2 is what is 8. I got 8 over 12. You're putting common denominators now. Yeah. Then you solve for this one. That's where you solve for that one here. Continue. Now when you add your 9 plus your 8, you get minus 17 over 12x is greater than or equals to minus 5 over 8. So you wanted to just get common denominators and bring them as 1. And bring the equation as what? As 1. And that's what we did here now. We got the equations here as 1. What equation is here as 1? So what equations here as 1? So we continue there. At the one already, now multiply both sides by the reverse of the equation. So we multiply both sides by this minus 12 over 17. So we brought 12 up and took 17 down to use to multiply this equation, because you can't multiply it the same way again. So your answer. So when it came in, now it's 17 over 12 and it's 12 over 17. When this cross this 17 here cross 17 here, 12 crosses 12, this comes minus 1 times x. Now this is minus 12, so minus goes. So here now we have isolated x to be on its own, and the same is done to the other side also. After solving everything, we got this. So now what happened here was 12 in 8. Yeah, 4 here will give us 2. 4 here will give us what? Will give us 3. So 5 times 3 will give us 15. Minus 5 times minus 3 will give us what? 15. 2 times 17 give us what? 37. So we are having our x as 15 over 37, because minus 5 times minus 3 is what? Is 15. The minus sign has gone. Minus sign has gone already. So minus 5 minus 3 will give us what? 15. And 2 times 17 give us what? 34. That's just the whole thing about inequality. So as we continue the class, we get to see more stressful and more complex equations actually, and expressions in 1 degree equation. These are just the basics you're meant to know as you're starting. But the more we're going to deep fractions, we're going to where they are combining all the equations together, like in our first degree equation I said yesterday. You go into first degree equation, you reach this extent where they are adding fraction, denominators, everything together, and for you to solve. So we are going to get to that place. Don't get to that place, we're going to cross it. That's just it. So thank you. Enjoy your video.